Okay. Let's pretend, hypothetically, that instead of this filling 1 gallon jugs of milk with 128 ounces, let's say it's filling it with 130 ounces. That's the goal, is to fill 120, mind you that? Okay, so 130. So I'll start right here. Whatever it's, however it's supposed to happen, that's our center line, what's expected. And in this case, we're hypothetically making up as if the jug should be 130 ounces. Well, with a standard deviation here of 2. With me? Okay, so I'm going to use standard deviation of 2. So plus and minus. You got to do both plus and minus, add and subtract. And then I'm putting 3 times standard deviations 2. Now the sample size. This experiment, this audit or whatever, this inspection was done 1, 2, 3, 6 times. And how many were grabbed, how many jugs of milk were grabbed each time the inspection was done? 25, yeah. So 25 is our sample size. Here's the number 1 mistake, accidentally thinking your sample size is 6 times. No, we did the testing 6 times. We're just reviewing, by the way, Tuesday's equation real quick. We did it 6 times, but the sample size for each time was 25. So this would be the square root of 25. Here it is. Whatever it's supposed to be would be our center line. Add and subtract 3 times the standard deviation over the square root of 25.
Is the sample size always given to you, or sometimes you have to figure it out?
No, the sample size is almost always given. Always given.
You have to figure it out.
Huh?
The homework, if you can't figure it out.
Well, let me ask you this, do you know, oh, yeah, okay, maybe I understand what you're saying now.
Yeah.
What you're saying, instead of the proportion being given to you, oh, no, we're on proportions, that doesn't make sense. No, okay, now, let's look at the homework. Hang on, let's do this.
Do you make it for this class?
Let's see if this will help. Okay, look at this problem right here. My question for you is, would you use this equation on this problem, and what would be the sample size? Are you ready? Would you use this equation? Random sample size of 100 is taken from a normally distributed population with a mean of 115, standard deviation of 22. Show your detailed calculations to determine the upper and lower control limit. Yes or no, would you use this equation? Oh, you should use that right away.
Yes.
Why? Wait, who else says yes and knows why? Yeah, go ahead.
It's asking for the upper and lower control.
No, not because it's asking the upper and lower. That's not how we know for sure to use this equation.
Show
Not because of the sample size either. That's not how we know to use this equation. You're getting closer. There's only like 2 more guesses.
Standard deviation.
Standard deviation. That's how we know to use this equation. If it's not giving you the standard deviation, we're using the equation we're going to learn today. That's how we know to use this equation, because it's got the standard deviation there of 22. All of these questions are asking for the upper and lower control limit. It's just a matter of figuring out, are we using Tuesday's equation, or we're going to use today's equation. And in this case, it was Tuesday's because it's giving you that standard deviation. Go ahead, you're going to add something. Did you want to add something to it? No? No? You don't want to? Yes? You want to add something to it?
Oh, no.
Okay, let's do the next one. Again, 2 is saying write the Excel function using confidence, which we're going to learn today, to be able to solve that same question. But let's go to number 3. The question is, as I'm reading this, are we using Tuesday's equation, yes or no? Says random sample, I forgot to say, what was the sample size on number 1? I forgot. Did we get that? What's the sample size for number 1? You got using
100.
that, what is it?
100.
100. That's right, it's given right there. They're all given. There's almost nothing you have to figure out the sample size. It's almost always given. Matter of fact, look at number 3. Random sample size 60. There, the sample size is given again. Was taken from a population with a given proportion of 82%. Show you detailed calculations to determine the upper and lower control limit. My question is, are we using Tuesday's equation?
No.
No, very good. Because it literally says the word proportion there, and it's giving you no standard deviation, and it's asking for an upper and lower control limit. And if you want to make today's lecture short, I'll jump right into the formula. Why not? We want to get out early. Is weather good or is it raining?
Great.
Yeah. Okay, we're not going to talk about that. It's raining. We're not in a hurry.
Could you just solve that further?
Solve that further. Order of operations says you got to square root that first. So that'd be a 5. Then divide it into 2. So 2 divided by 5 equals 0.4. Then multiply it times 3. So 3 times 0.4 equals 1.2. Now add and subtract that 1.2 to 130. 130 plus 1.2 is 131.2. 130 minus 1.2 would be 128.8. But remember, this example is not, the example I have up there is not about 130. It was about 128. I only made up 130 as hypothetically, so we had an example we could talk about other than the one we already talked about. Go ahead. Okay. That's the only reason I used 130, so don't look at the book for the answer on this one.
Would you multiply by 3 before adding it to the one?
I did multiply by 3 before adding it. 3, this came out to 0.4, then multiply by 3, then add and subtract it. Adding and subtracting from the center line is the last step. Adding and subtracting to the center line is the last step. Well, everything to the right of it has to be first. And you got to do that square root before you divide it into the 2. So, you just grab your stuff on your way out, okay? All right. Number 3, we know that it's not that equation, it's going to be the new equation. Number 4 says use the Excel confidence equation. You know what I forgot? We didn't cover the confidence equation. Yeah, nothing changes. What am I doing? Boom. I don't know what I'm saying. Let's keep going. 5, tell me which equation. A production process is designed to fill boxes with an average of 24 ounces of cereal with a standard deviation of 3 ounces. Show you detailed calculations to determine the upper and lower control limit. My question is, are we using this equation, yes or no?
Yes.
Yes, because
Standard deviation.
standard deviation. My question is, what's the sample size?
12.
12, very good. 12.
Right.
All right, I think that's it, right? Only 5, or do we have a 6th one? Oh, we do have 6. Again, it's just the Excel equation. So we have 3 problems and 3 Excel equations for each one of those 3 problems of what's going on. There's the 6. Okay, who's done? Because this homework was too easy. No one's done? Oh, I can't even believe it. Shot. All right, so now what do I want to talk about? Since we're completely out of order of whatever I had prepared here, let me just see. Oh, I have a bunch of reminders. Here's our reminders. Last day for old late submissions, there's still some zeros out there, is Tuesday, 5 days from today. Is your last time to be able to old late submissions. Not something from week 13 that's due Tuesday anyway, that's not part of this. This is anything before that if you look back and you got a 0 on something. Last day to get, after the 16th, I'll still take it, but the highest you can get is 20. It's another 50% off 40, the 40's the highest you can get now. Last day for participation is the day of the final, the second half of the final, which is Tuesday the 23rd, week and a half from now. Final exam part 1 is a week from today, 1 week from today. And I forgot to put the time. What time does our class start? 9:30, thank you. And then Tuesday, that's right, Tuesday on the 23rd, 5 days after the first part. This is at 9 a.m., not 8 a.m., not 9:30, this is at 9 a.m. How much is your expected time? Since I haven't started writing this yet whatsoever, I can only guess that the first part is gonna be around, I'm gonna say 45 minutes is gonna be your expected time limit. The second part should have an expected time limit, I'm gonna guess an hour. That's my guess, good enough.
The finals in this room, right?
Yeah, both days, everything's in this room. So we're, after today, 1, 2, 3. I only have to drive here 3 more times, which by the way, a 59-minute drive. You got along today.
From where? Where do you drive from? If you don't
All the
mind
way
me
from south of Flint.
Wow.
84 minutes today. I left early knowing this could happen because Tuesday after I left here, I was looking in the lane on the way down as I was heading back home and going, oh my God, that traffic's backed up for hours. So I left way early today knowing I was gonna hit that, thinking I'm so early, I'm not gonna even have that kind of traffic. So many people have to go to work so early in the morning, it's crazy.
What time do you have to get up?
I was up today at 4:35.
What time do you sleep?
I fell asleep in my recliner and I'm in pain for doing so at about, I think I remember seeing 9 go by, I don't know if I made it to 10 or 9. Somewhere in there. I know I got 6 hours, what is that, 10 to 11, 12,
Always
plus
wondered
4,
what
10 to
time
4.
sleeps.
That's 6 hours,
Cause it's like,
right? A
he
little
gets
more
here
6 hours, what are you talking about?
at 12.
I don't know, when you give me those looks, I sleep great.
It's just because you take so long to come here, so like.
I'm sorry?
Like 84, my time was 120.
Yeah, I know, that's a long time, and if there were no traffic and things were normal, less than 60 minutes to get here.
That's good.
Like 58, I've made it. It's only been in the, see, 2 years. For 2 years, we all stayed at home and I stayed online. But then, these last 2 years have been driving here. Driving here, I've only made it in less than 60 minutes twice in 2 years. Just twice, so every other time it's taken longer than 60 minutes.
Didn't you make it recently too?
Good thing gas is so cheap.
Well, here's the weird part. Wow, I've never seen such a variety of gas prices so far apart from each other. Has anybody looked lately?
Yeah.
Yesterday, I saw a ton of 379s. 379 seemed to be the going price for a while. Then all of a sudden, I saw 349. I thought, well, that's weird. Then 318s, which were out in the booty somewhere, and one 298.
Dearborn usually has the cheapest.
Who did, where?
Dearborn.
Dearborn usually has the cheapest.
And has anybody gotten any today?
It's like 320,
It's
330.
like 335.
Oh, yeah, it went up a little bit.
337, 335? Well, look, we got time. Let's just look. Last time we looked, which was a long time ago, oil was at around $80 a barrel, if I recall. So let's see what it is right now. Crude oil is right there, 80, how do I get rid of this? Let me scroll down. 85.57 a barrel right now, down 64 cents. But it's more than it was when we started the semester. So if my logic's correct, there's a sure correlation between gas prices and crude oil. Gas prices should be a little higher than they were when we first started the semester. If I recall, at the beginning of the semester, it was right around $3 a gallon, maybe?
Yeah.
302, 304, and now it's more like 350, somewhere in there. Let's look at Bitcoin. Remember that when I was telling you how Bitcoin was taking off like a rocket? Well, it settled.
70.
It stopped taking off. It's right around $70,000 a coin. Let me see where it's at today. 69. What is that? 898. So about 69,900.
So 2200.
Real quick. All right. This is a big indicator as to what's happening with interest rates on savings and loans, called the 10-year bond. 4.52 is a little higher than it's been lately, which means then interest rates will be a little higher. If you're right now trying to look for a car loan or a house loan, it'll be a little higher than it was maybe a week ago.
Did they say they're gonna cut rates this year? I know they came out with something yesterday.
They're talking about cutting rates, but they're saying they're so afraid inflation might try to come back that they're putting off cutting rates. So that's why you see the market should be down a little because of this announcement. This was just this morning, actually. How do I get back over here? And sure enough, the market is just barely down, just down a little bit. What is that? That's up? So the NASDAQ's up, but S&P's kind of like the whole market, and it's just down a hair. Speaking of 0.0, look at, what would you guys call that? It says negative 0.02 and then a percent symbol. Let's change that to a decimal. I want to say that again. This is point what? Is that 0.2 or 0.02?
Now it's 0.01.
0.01, okay, we'll go with 0.01. It isn't even 0.1%, it's 0.01%. Now listen, that's not 1%. That's 0.01%. Let's change that to a decimal. When you get rid of that decimal, the percent symbol, you're moving the decimal 2 places to the left. So this is the same as 0.0001 if that were a decimal. This one, you move it 2 places left, 0.001. Okay? Now I want to make sure we stay on track with this. What if I said something is 0.27%? What would the decimal be for that? That's right, 2 zeros. You got to move it 2 places. 0.0027. Now let's not forget this. We got to come back to this right here. All right. So anyway, don't worry. We got lots of time.
So inflation is still expected to go up?
Hopefully it's under control, but because they're not sure, the indicators are saying it might be under control, may not be under control. We're not going to lower interest rates. They don't want to repeat what happened in the 1970s. You guys were not even thought of in the 1970s. Your parents weren't even met each other yet in the 1970s. But the same thing happened, we had this huge inflation, and then they raised interest rates, tried to get it under control, then lowered interest rates too quickly, inflation came back, they don't want that to repeat again. All right, so now, let's go with, let me look here. And then essentially we went over that, oh yeah, you know what I need to make sure you remember? If you haven't done this already,
That's a
again, let me emphasize, do not show me any answers, they're completely anonymous for your evaluations of the course. It's just after you're done, there's this page that shows which ones you completed and which ones you haven't. Just do a screenshot, email it to me real quick, it's a very small part of your participation, but it's such an easy part of your participation, you might as well get it. So there's your reminder for that. So now, let's go to, I'm gonna go right here. Let's look at our first proportion problem. Here it is. Here's our first proportion problem. Let me start by explaining the equation to you. Just like last Tuesday's equation, center line plus and minus 3 times the standard error of the mean. This one is center line plus and minus 3 times standard error of the proportion. That's the only difference. Instead of, in the parentheses, instead of standard error of the mean, standard error of the proportion. Let's review standard error of the proportion. It's the given proportion, which is going to be your center line. Let me repeat that. That proportion in the formula and center line are the same number. So it's the given proportion times 1 minus the given proportion, so the opposite of it, divided by the sample size. Now here's the tough part, square root the whole thing. Some of you handed in chapter 12's homework and had just the top part square rooted and not the whole thing. So I want to make sure you realize that when it comes to the standard error of the proportion, that whole thing is square rooted. Yes, the standard error of the mean, just the sample size is square rooted in the denominator. That's the difference here. But here, the whole thing is square rooted. All right? It's a very easy formula. There's the manual formula. So we'll talk about this using the manual formula. Here's a proportion. Instead of a mean and a standard deviation being given, it says, hey, the production process at this company has 5% defective rate, and they can't go outside of 5% defective rate. It says the quality inspector takes 6 samples of 500 each, so there's 500. Let's pretend these are like ball bearings, and they got to be a certain diameter, or there's not supposed to be any divots in it whatsoever. And so we're going to grab 500 of them at random after a production process and put them quickly through a machine that spins it and checks for defects and counts how many. And then it takes however many were defective and divides by 500, and here's the results from doing this 6 times. 0.065. 6.5% were defective in that first 500. The second 500, 0.075, about 7.5% defective. 0.082, 0.086, 0.090, 0.092. There it is. Now, we gotta find the upper and lower control limit to determine whether these are within those limits. If these happen to be within those limits, we let the production process continue. But if these fall outside the upper or lower control limits, especially the uppers, really, and when it comes to defective, by the way, you usually only use the upper control limit. We're pretending like this is anything. Upper and lower control limits, if these fall outside, we're supposed to stop production, make adjustments to the machine to get it back to where the ball bearings or whatever we're producing are back inside the stack, the 5% defective rate. So here we go, let's calculate it. Where's my blue pen? What is going to be our center line here? What's the goal? Give me, not all at once, come on, we're recording this. What's the goal? What's going to be the center line in this calculation if this were a problem on your final?
0.082?
No, not 0.082, where'd you get that? Oh no, that happens to be one of the outcomes from grabbing 500 of them. What's our center line? What does the contract say between us and the company that we're gonna make these and we're not gonna have any more or less than what percent? 5% is our center line. So here we go. 0.05, there it is. Plus and minus, I'm just writing them as one because you know you gotta do both plus and minus, add and subtract. 3 times, I don't even need to look for another number. The same number on proportions you're using as your center line is the same number you're gonna use in this equation. So this is gonna be here we go, 0.05 times 1 minus 0.05 divided by, what's our sample size?
6.
Wait, come on, you guys, hang on a minute.
Wait, 6 samples.
Stop,
My fault.
stop. I just got done talking about, remember, it's not about how many times we do it. It's about how many were in each one of the inspections, which were how many?
500.
There you go, 500. Not how many times we do it, the 500. Square root has to be over the whole thing for standard error of the proportion. Square root the whole thing, parentheses. There's the points. Setting that up. Yeah, you should be writing 2 equations, but if you're pretty good at saying plus n minus, I'll just put the word n there. How's that? Plus n minus, you can write it as 1 equation. I'll take that. Now, on your homework, show me at least 1 calculation. You're going to need to do more than 1, and show me as many as you should be showing me, but if you want to get full credit on the homework and on your final exam, there should be at least 1. Either this times this, or this divided by this, or the square root. Matter of fact, there probably should be 2 at least, because there's like 3 calculations you could be doing here. So show some calculations and then show the outcome. Let's look at the calculations as if we did, because order of operations would say 0.95 times 0.05, right? That's the opposite of 0.05. 1 minus 0.05 is 0.95. Times 0.05, divided by 500. There's a number. Then square root it. There's a number. Multiply it times 3. There's a number. And what are those numbers? Let's look. There they are. We did all the math on it. The upper control limit, adding that to 0.05 would give us 0.079. If we subtracted all this times 3 from 0.05, we get 0.021. 0.021. Now, you're going to show me your work on the final exam. You're going to show me the upper and lower control limit. But on the final exam, that's not on your homework. There's one more question. Should this machine be stopped, or should we continue letting it make ball bearings? I can't hear you. Wait, come on, today.
I know how to do it.
Continue.
You can
Because
continue.
it's in between the numbers.
Yeah, it's not higher than.
Oh, is it?
It doesn't go higher and doesn't go lower than the.
Okay, what's the upper limit?
No.
I can't read it. I think
Yusuf, you want to jump in on that?
0.0.
92.
Wait. Did you guys hear that? He said he would stop it because he said a couple of those outcomes, and he used 0.029092, I think is the one you said, as an example, is above that upper limit of 0.079. Just having one of them above that upper limit tells you must stop this machine. What's the other one? 0.090 is above 0.079. Another one that tells you got to stop it. Let me go one back from there. 0.086, also above 0.079. 3 of them telling you got to stop this machine. You should have stopped it a while ago. The 4th one, where's that one? 0.082, also above 0.0. Matter of fact, only the far 2 left ones, 0.075 and 0.065, fall between the upper and lower control limit. Remember, all of them must fall between the upper and lower control limit for you to say this machine can keep going. In this case, it's got to be stopped. Let's see if there's a control chart. If you had to draw a control chart, could you do it?
Yeah.
What would be, okay, you got 3 lines here. You got, first of all, here's the chart. You got your center line. What number would be on the left here on this center line? 5%, 0.05, very good. You have your upper control limit, you have your lower control limit. What number would be listed on this if I said make a control chart? What number would you put at the top? That's right, 0.079. And then what number would you put at the bottom one? 0.021, very good. And maybe, how many were there? 6 of them? So maybe 1, 2, 3, 4, 5, 6. You probably should put dots where you think they're gonna land. Where's the first one? 0.065 would be, I'm gonna put it right, I'm just gonna put it right there. That's pretty close. The second one is 0.075. Oh, okay, hang on, we're gonna put that.
Closer to the top.
About right there. It's not 0.079, but it is 0.075. But then look at the next one, 0.082. Here I go. I'm not gonna have room on here. I'm above the upper limit right there. Number 4, 0.086. Oh my gosh, I'm gonna have to write on the wall. I can't do that, can I? There it is. Hang on, number 6. hang on. There we go. Look at how 3 of those are off the chart, not even on the board. Literally doing damage to drywall that I'll have to pay for. That's how much we gotta stop this machine. That's what it's trying to tell you. I think we got one. I don't know if we have one here or not. Oh, I hate it. What slide was I on? I forgot already. 4:13. Went the wrong way. And so the lesson is, don't grab that little thing to move it. You gotta just put it. There it is. Oh, and look at this. There's the control chart. They put just some round numbers at the bottom and the top, but I like to have the exact upper control limit, which is right there, 0.079. The lower control limit, 0.021. There's our center line, 0.05. Look at the dots going off the chart, just like we did. So you can draw that, right? This is almost too easy, isn't it? I think I got another example though. We're gonna get to the Excel, and then it gets hard though. So don't get bored yet. Let's do it. Matter of fact, let's go right to Excel right now, because then we can go ahead and check these and make sure we get the same answer. All right, are you ready? Hang on, let me move this up so we can see the upper and lower control limit and see if we get the same answers using Excel. We're gonna come back to the screen right here. But here's Excel, right here. It's the center line, you add and subtract, so there's 2 Excel equations. You use the word confidence. Parentheses. Now this says norm S distribution, NORMS parentheses, negative Z. However many standard deviations the control limits need to be above and below the center line. We, in this class, are assuming for our final exam, for our homework, 3, right? We're always using a 3 here. This is the number of standard errors above and below our center line. We're using a 3. So this Z is gonna be negative 3 times 2. We're using a 3. But in real life, and when you get to operations management, and when you get to advanced stats, you're gonna have some companies that don't use 3 standard errors. Sometimes they use 2 standard errors, or maybe something's gotta be just perfect, then they're only using 1 standard error. In that case, you gotta change that number for the first number in the confidence. But for this class, since we're assuming that's gonna be a 3, I'm gonna tell you what it calculates out to. 0.0027. Because here's what we're doing. You ready? Where's my pen? Do you remember the empirical rule? You guys remember the empirical rule?
Yeah.
Okay. It says there's a certain percent underneath this bell curve that's always within 1 standard deviation, then 2, then 3. The empirical rule says 3 standard deviations to the left and to the right of the mean proportion or mean number is going to be 99.7% of the bell curve. This first number has to represent what percent of the bell curve is in the tail. What percent of the bell curve is in the tails, and that's what you're calculating by using this norm S distribution negative 3. Let me give you an example. Let's do the math on this. If 99.7% is written as a decimal, it looks like this. And that's going from all the way from negative 3 to positive 3. So the opposite of 99.7% would be in the tails. The 2 tails added together, because this is in the center from 3 to 3. So if you take 1.000 minus 0.997, you'll have what's in the tails. But remember, the empirical rule is an estimate. It's not a firm number, okay? So in this case, you're getting 0.003. In those tails are only 0.3%. Because there's less than 1% left after 99.7%. There's only 0.3%, so write it as a decimal. But here's the deal. Empirical rule estimates. Norm S distribution gives you the exact number. So it's not 0.003, it's 0.0027. because we're going 4 digits. So that can be your first number on every one of these equations on your homework and on the final exam. Let me repeat that for you guys. Are you ready? Everybody hear me okay? That first number on your final exam and on your homework, if you're using Excel to solve these, is going to be 0.0027.
Can we just leave that as -3?
You don't even have to use -3, you don't have to use norm S, you can just put 0.0027 if you want. It's up to you. Go
What would
ahead.
the Z be?
Huh?
What would the Z be?
The Z would be a 3, because we're using 3 for this class, and on the exam, and on the homework. We're using 3 standard errors above and below the center line. So now that you know the first number, let's solve 2 different problems. One, a proportion, and one with a mean and a standard deviation, using Excel. Because they're almost done the exact same way. The only difference is that standard error, that third number, or I'm sorry, that second number. And then the sample size is the last number. All right, so let's go to this problem we were just talking about right here. In this problem, let me go back to the top. We were looking for defective parts. The contract says we can't have more than 5% of defective parts. Whoops, I gotta get the sample size. Hang on, I gotta go up here. There we go. So I'm gonna do this proportion one using Excel. Ready? Equals, center line in this case was 5%. Equals 0.05, I'm gonna do the plus, because there's also a minus, but same exact thing, but a minus. Confidence, C-O-N-F-I-D-E-N-C-E. I don't know what's going on with this board. Where's the pen? Yeah, maybe it's the pen. Confidence, the first number is 0.0027, parenthesis, comma. Look at what I did. I used 0.0027 because for this class, I know that we're using 3 standard errors. So I know that number is going to be 0.0027. Comma. Standard error. In this case, it's a proportion. So the standard error is right there in the parentheses. Without the sample size. Without the sample size. Right there in the parentheses, but without the sample size. So here we go. S, Q, R, T, parentheses. 0.05, asterisk, parentheses, 1 minus 0.05, parentheses. Okay, let me repeat that. This is the hardest part of this week's lecture. Let me say it again. The second number is the standard error without the sample size. We're going to do another one that's using standard deviation and the center line with a sample size here. We're going to do it on Excel in that case, but again, it's the standard error without the sample size. So in this case, the only thing that's left without the sample size is the standard deviation. But we're doing this one right now. In this one, the standard error without the sample size is the square root of the proportion times 1 minus the proportion. So that's what's going there. The square root of parentheses 0.05 times parentheses 1 minus 0.05 parentheses, comma. Now what's the sample size of every one of these 6 inspections? Say it again.
500.
Very good, 500. Parentheses. There it is. Now, if I did it right, it should come out to 0.079. Here we go. We have to open this up. Here equals 0.05 is the given defective rate that our goal is, plus the word confidence. There it is, confidence, parentheses. Now, right now I can put norm S distribution, parentheses, -3 asterisk times 2. But I know it's 0.0027. I'm giving that to you. I'm allowing you just to put the 0.0027. But I'm going to put the whole equation in, because this is really the proper way to do it. But you're allowed to put 0.0027. The equation itself would be norm S, DIST, parenthesis, -3, parenthesis, asterisk 2. Because norm S is finding what amounts right there in that tail, and we gotta multiply times 2, because we gotta have both tails. We gotta have both tails when we're doing upper and lower control limits. Comma. Now here we go. Square root 0.05. SQRT, parentheses, 0.05, asterisk, parentheses, 1 minus 0.05, parentheses, comma, 500, parentheses. If I did this right, it should come out to, I forgot already, hang on, I gotta bring this up. 0.079, let's take a look. 0.07924. Everybody see how I did that? The only difference now for the lower control limit is switch that plus to a minus. That's the only difference. And so I'm gonna switch it to a minus, and of course, if I did it right, whoops, it should come out to, I can't read it again, 0.021. So here we go, I'm gonna switch it to a minus, right here, boom, minus, 0.02076, 0.021. Now, just to show you, I'm now gonna take that norm S distribution, -3 times 2, and change it to 0.0027. All right, so I'm gonna change it back to a plus. Here we go. Oh, I hit the wrong key. That was look what happened. Got rid of it completely. Change it to a plus. Change this now to 0.0027, and it should be darn close to the same answer we had, which was, I gotta remember now, 0.079. So here we go. 0.07924, same answer. Are we getting it? Okay, now you need to see an example of using Excel confidence, but with a problem with the standard deviation. So we gotta see an example of that. So we're gonna go back to the jugs of milk. Why not? Let me scroll up. Okay, there we go. We're gonna do 25 jugs of milk every inspection. The amount of milk that should be in each jug is 128 ounces, plus or minus. Standard deviation of 2. Here we go. Where's my eraser? Okay, same thing, but again, we don't use the sample size for that standard error. We take that part out. So we're only using the standard deviation actually. Center line equals 128 ounces. Plus and minus, I'm doing the plus right now. Confidence, CONFIDENCE, parentheses. I'm gonna put in the 0.0027. All right, I'm just gonna put 0.0027 this time instead of the norm S. Why not? Now, this number is the standard error without the sample size, which only leaves the standard deviation, 2. The standard error without the sample size, all it leaves is the standard deviation. The last number is the sample size. How many are taken into each inspection? 25. There's the 25.
You're not gonna do a square?
That's it. That's it. You don't have to do square root or any of that. So let's test it out. Let's test it there. If we're correct, the upper limit should be 129.2. So here we go. Equals 128 is our center line plus CON, confidence, parenthesis. That first number is 0.0027, which is 3 standard deviations, 3 standard errors, comma, our standard deviation, or our standard error without the sample size, is our standard deviation, which is a 2, comma, the number in each inspection is our sample size, which was 25, parenthesis. Again, if I did this right, it should come out to,
129.
thank you, 129.2, 129.2. There it is. This is for using this one, Tuesdays. And if I had put 128 there, that would be the exact same one we're talking about. But we did 130 just to do another example. How do we feel? Can we do these? Okay, now look, I need to, this is not gonna be on the final, but I need to know that you understand this. We just came across a company who's also doing milks a jug. They're also doing 128 ounces. They're saying 2 ounces standard deviation. They're also using, hang on, I gotta put that back up there. They're also using 25, and they're gonna do the inspection 6 times, but they're only using 2 standard errors in their inspections, not 3. This will not be on the final. I'm just trying to give you real life. We need to calculate the upper and lower limit, but in this case, not 3 standard errors, 2 standard errors. Help me write this equation. Let me get this out of here. Again, because I said everything, we almost don't have to do, we're almost writing the exact same equation. Said another milk company, 128 ounces. We're gonna look for the plus, we're gonna do the plus first. We gotta do the word confidence. Okay, parentheses. What goes here?
0.0027.
No, because this is the whole point of this one. Go ahead, no. This time, the company's saying, oh, we're only using 2 standard errors, not 3.
You put norm as
Oh,
dis.
Norm S dis, but the
Negative
-2. That's it, exactly. You don't have to put an equal sign, because we're inside parentheses here. We're not at the beginning of the equation. Norm S dist, parentheses, -2, parentheses, asterisk, times 2, comma. That will give us different upper and lower control limits compared to the first milk company who's using the standard 3 standard errors. This company's saying, no, we're only using 2. So this is how you calculate the upper and lower limit. The standard deviation, the standard error without the sample size is the same, 2, comma. They're also using 25 gallons. Every time they pull it out, they're doing the same thing. The only difference is that this number in front will be a different number. Now I want you to imagine this bell curve. This company isn't using 3 standard deviations, they're using 2. So this is what they're talking about. Their upper and lower control limit only goes here and here. The tails will be different. The tails will be different. So my question for you is, if I were to calculate that number right there, which represents the percent out of 100% that's in both tails together, would it be larger or smaller than 0.0027?
Larger.
Larger. There's definitely more area in the tails when you're using this, which will bring the upper and lower control limits down. This upper control limit will be lower than it is when you're using 3 standard errors. This lower control limit will be higher. It'll bring them both in tighter to the central number because there's less room then to have errors. That's how it works. How are we doing on time?
10:19.
All right. Let me see what else I have here. Did I do, okay, here we go. This is what else we're getting. By the way, all this I've been showing is on page 262 from your book. I just haven't been using this PDF, but it's page 262 for your book.
How do we know which equation to use?
If there's a standard deviation, you've got to use Tuesday's equation. If it's a proportion, you've got to use this equation, no standard deviation. So now we're going to do a couple of problems. I just want you to set them up for me. This is going to be page 265 from your book. What slide is this? 417. What number? 42. Okay, help me with 42. Here we go. Let me erase this. Let's set it up manually. Let's set this up manually. I'll read it out loud. Random sample size 500 is taken from a population with P equals 0.34. Construct an upper and lower control limit. We have all the information necessary. How many start writing this? What's the center line? Let me look, I almost forgot. What's center line? What is center line?
0.34.
0.34, number 42. Plus, there we go, 3 times
Square root.
0, yep, square root, thank you. 0.34 times 1 minus 0.34, parenthesis, over 500. Square root the whole thing, parenthesis. Look at that, that is how you set it up on the nose, 500, you're absolutely right. Let's do this now using Excel. Don't forget, you're not, do the same thing for a minus though.
Equals.
Excel would be, what would be the equals?
0.34
0.34 plus confidence, hang on, F confidence.
0.0.
The first number, here we go. That's right, 0.0027 parentheses, or comma. Now, here we go.
Square root.
Square root, very good. SQRT, parentheses,
0.34.
0.34 or 0.34.
Asterisk.
Asterisk, very good.
Parentheses. Parentheses 1.
Asterisk?
Huh?
Is it you? Who's that though? You guys?
Yeah.
Here we go. Parentheses, 1 minus 0.34, parentheses,
Parentheses. Minus
comma,
500.
500. There it is. There it is. Oh, these are too easy now. I know it's the Excel, it makes it a little difficult.
No, why do we have to put an asterisk for that one, but not next to the square root?
The square root is just telling everything between the parentheses has to be square
I
root,
mean,
they're not
no, my
multiplied.
bad. Okay. That makes sense.
So this is the only place multiplication is taking place is right there.
So every multiplication you have to put an asterisk?
Every time there's multiplication in Excel, you've got to use an asterisk. Putting numbers next to each other, Excel cannot figure out that that means a multiplication. All right, here's my question. Again, let's do this. Let's do this real quick. And then I'm gonna ask this question. I'm gonna write these two answers down. So this is equals, you just said, 0.34 plus the word confidence, parentheses, 0.0027, comma, SQRT, parentheses, 0.34, asterisk, parentheses, 1 minus 0.34, parentheses, comma, 500. Our upper control limit is, you ready? Read that to me, point what? 0.4.
You put the cursor on those.
403, what's the rest?
5, 6.
5, 6?
Is it 5?
554.
No. Wait, what? We're doing 5 numbers? Oh, yeah.
Point 0.403554. 0.403554. Okay, let's get our lower limit. What do I gotta do to get the lower limit?
Oh, you just use the
That's right, just switch that plus to a minus. Hit enter. There it is, 0.276, 0.2764.
6.
There it is. Okay, there's our upper control limit, our lower control limit. Here we go. I want you to pass this question on the exam. And it says, hey, look at number 42. Look at B. 0.28, 0.30, 0.33, 0.34, 0.37, 0.39. Should we be stopping this machine or continue production? I have 1 continue.
Continue.
I have 2 continues.
Oh, continue.
I have 3 not paying attention whatsoever.
Continue.
Continue. That's 3 continues, 4 continues, I mean. Because every one of those numbers fall between 0.276446 and 0.403554, we continue. Only if one of those numbers fell outside of those upper and lower control limits would we stop that machine. And you will be asked to analyze that. That's the only thing that makes this at least semi-challenging at all, is for you to analyze whether you stop or keep the machine going. Go ahead.
Like I said earlier, will we actually have to drop the grass on the final?
Why is there a what?
Will we actually have to drop the grass on the final?
Maybe. If I ask for it though, so I'm asking for 3 lines. You know, I mean, odds are slim, let me put it that way. I haven't even started writing it, but I can't imagine,
You stop.
there's so many questions that could be put on this final exam because the semester, there's 14 weeks worth of material that, I would say that if you had to be, don't forget, by the way, if you show up Tuesday, you're gonna hear the list of things not to study. But I would say that if you focus on the most important points of the semester, hey, like for example, do you think there'll be an exponential problem on there?
Mm-hmm.
Of course, but what you have to figure out, what you gotta say to yourself, would it be a written problem or would it be Excel? And then just be prepared for either one. Do you think there's gonna be, a Poisson problem on there?
Yeah.
Of course there's gonna be, but is it gonna be written or is it gonna be Excel? And be prepared
Excel.
for either one, that kind of thing. I would say most of the points are in the problems, just like quiz 1, 2, and 3. And then there's a certain amount of multiple choice, just like the quizzes. Nothing's different from this final exam than there is from the quizzes, except for it's broken up into 2 parts. And the only difference between the 2 parts is that on a week from today, it can only include weeks 1 through 13. It can't include week 14. And then the Tuesday after that, on the 23rd, includes weeks 1 through 14. It will include week 14. So that means what we're gonna learn on Tuesday of next week can only be on the second half of the exam. That it can't be 2 days later from the time we learned it on the first exam. Yes?
How many questions?
I haven't started writing it, but I know my goal is to try to make the first one have a time limit around 45, 50 minutes. So I would guess that's gonna be around 8 or 10 questions, does that sound right? And then I know my goal is to try to make the second part around 60 minutes or so. So in that case, I bet we're looking at 10 to 12 questions maybe?
Not bad.
Does that sound right?
Yeah.
So it's basically 2 quizzes. It's just 2 quizzes. One's a little shorter than the other. Now here, if you're trying to figure out how much new information, how much old, I would guess that, by the way, these are being graded combined as one test. And I would guess that between the 2 of them, I would say 40% is gonna be the new material from quiz 3 forward. 60% would be older material from quiz 3 back, would be my guess out of the proportion. Does that sound right? Sound about right? Approximately?
Do you choose the exam to be cumulative? Like, do you,
Yeah, I chose it to be cumulative, is that what you said? Yeah.
like you get the choice to choose it?
I can choose how to make a test, what do you mean? Do you get the
No,
choice?
I'm saying like, do they give you the choice to do it cumulative or not?
Who's they?
Like the university.
The university.
Yeah, they don't give you any instructions other than,
Okay.
I remember once they said, make it a little longer, because mine was too short. That's about the
Yeah,
instructions
I
I
think we
got.
should take that.
So that's why, this used to only be 1 hour, the whole exam was 1 hour. So now it's an hour and 40 minutes. Would you say why make it longer?
60 minutes for part 2.
They told you to make it time-wise or?
Just make it longer, make it more. It was like a more to it. Like the final exam should have more to it.
Do it.
That's the only thing that's the only advice I was given one time, I don't know, about 3 or 4 years ago. Here, at this campus. You know why my exam became really short is because when we were in COVID, everything shortened up. Man, it's the best time to have taken classes was during COVID, because you really, all the rules were bent. Everything was out the window and everybody got away with everything. I wasn't even taking attendance because you guys didn't even have to turn on your cameras during COVID. You didn't know, they could be there attending and just see their name. There's just a black screen. I have all these little black squares.
So we gotta show up at 9, not 9:30.
On Tuesday the 23rd, 9 o'clock. It's your schedule for 8, I moved it up to 9.
Oh.
Thank you.
Thank you.
I know, it's at 7:30 in the morning.
We're gonna get an email about this, right? About the-
An email about this? No, it's on the instructions for the last couple of weeks, and it'll be on week 14 also. Right at the bottom of the instructions, it has all that detail. Last day to hand in old submissions, 4/16. Exam reminder, part 1's on the 18th, part 2's on the 23rd. The only thing that's not on the instructions is the time, because the other class is a different time than yours. Normal time on a week from today, 9 a.m. though on the Tuesday after that. Normal time, 9:30, 9 a.m. on the Tuesday after that. But yeah, no, this isn't. On the announcements, I'll show you what I do have on there. Here's what it says right now. So tonight, I'll switch this to say only 1 more lecture, and I'll get rid of this 4:11. And then it says 4:16 is the last lecture, 4:18. Your class says 9:30 on announcements, and then it says part 2 at 9 a.m. So that is up on announcements on Canvas. Now, when I post up announcements, some of you who are signed up on the Canvas app probably get an email that says I posted this, right?
Yeah.
Okay.
Yeah.
If you're not getting an email when I put an announcement up, you wanna get, somehow turn that on your Canvas app, because this is, I posted very few announcements, they were very important when I did, so you wanna get those, announcements if I have any for the rest of the semester, because that means it's something really important. Any other questions? Let's do our in-class assignment. I have a life lesson, but we don't need one here.
Give it what we do then.
No, instead of the in-class, is that what you just
No,
said?
while we do this.
Oh, why you're doing in-class? I don't know, you guys need to focus. Okay, can you see it okay?
I like your life lesson.
Okay, this in class is preparing you for your homework and for the final exam. There's two parts to it. Here, I'll read it to you. A production process.
Can you zoom in?
Oh, you can't see it? All semester, I've played this trick on you, and it never grows old. A production process is designed to fill beer bottles with an average of 16.9 ounces of wine. Now, you can tell.
see it?
Hang on a minute. Hang on a minute. I meant beer. There we go. This saves. There we go. A beer with a standard deviation of 1.2 ounces. Show your detailed calculations to determine the upper and lower control limit for a sample size of 25. The second part says, write two, not one, two Excel function equations using the confidence function that would calculate the same upper control limit and lower control limit from the question above. Let me erase this. This is too easy.
Wait, chill.
I'll just erase this right here. So you don't have
Tie it
that.
to my notes.
Just this right here. So now, here's the only hard part about today's in-class assignment, is that it's reflective of Tuesday's lecture and part of today's lecture. It's not this equation, it's Tuesday's equation. There's the big if. Did I have a walk down that song? You guys have got to turn off the camera, so I just heard your whole conversation. I'll make sure I'm watching.